Hi, welcome to 2021 and welcome to the first objD update of this year. As always, there are a ton of features included in this update, but one thing I want to focus on in this video is the new annotations. So what are annotations? To simplify it, you can write data packs in objD now with fewer lines of code with these add symbols here. And today I want to dive deep into this topic, explain how it works and how you can activate it for your objD project. So if you ever worked with objD, you might encounter situations like these, where you had all these nesting widgets here. It works perfectly, but it is a bit unorganized and honestly a bit hard to read with all these brackets and so on. Well, of course, one solution for this is to split up your project into separate widgets, so you get a coherent folder structure and have each functionality separate in its own widget. And yes, it looks a lot better. You can organize things, and I would always recommend this. But if you look at some widgets here, they are quite lengthy, and honestly, you have to write a lot of boilerplate code. Like all the input values you want to have, the constructor, then this override here. This is not really necessary. So I went back to the drawing board and asked myself, what is the essence of these widgets? Well, we want to reuse them somewhere and just want to have to write one piece of code that generates the commands for it. And then you also might want to have some inputs here. Well, that sounds pretty similar to a function. So this would be pretty similar functionality, but you can see this is a one-liner. This is much easier to recognize. So the entire idea behind these annotations is to make everything a bit more simple, and that's where code generation comes in. I'll go quickly on how to activate this. Make sure you have the newest version of objD, so in this case 0.3.5. And then you also want to have a new field called dev dependencies here, build runner. You can leave this empty here, it will just take the latest version. And then also objD gen. So these two packages here actually provide the functionality to do code generation with Dart and also with objD. How does this work? In this package here there is the add WDG, which obviously stands for our widget. And this is responsible to express a widget using a function. So here write our function again. Again here it takes a string and it returns the terror widget with the name in it, like we've seen with the usual widget. So now what is important is that this is a feature of Dart and not that much of objD. That means what this code generation will do is it looks at this function here, determines, oh, it takes a name and so on, and then it will generate a widget class for you. So it will generate a new file in our lib folder here called annet.g.dart, and to make sure that everything that is in this new Dart file is also available in our file here, we have to use this part definition. So here we just write the file name again, but with a G in the middle. And for now it will say, oh, it has not been generated, and of course you can't see any file here. But that is where this build runner package comes play. Here you just type pub run build runner build. And now for the first time it will take a bit, but it will basically analyze your Dart code that you've written and apply the objD gen package to it. So there it succeeded. And now we can see there is a annotation g.dart file here, which has a widget class in here. And you can also see it inherited our string name here. generated this constructor here for us, and also the generate method. This just invokes your function here with all the parameters that you defined. So I hope the idea is clear. For this part here to exist, objD didn't generate anything, but Dart itself generated a class in Dart that resembles your new widget. But the big advantage is that you can use this function here to define a widget, and of course you can also give it multiple input parameters here. So let's say we want to have a named parameter, and that should be the color of our text right there. And by default this should be color.red. So let's exchange this right here, and now the g.dart should inherit this. Not really. This is a slight disadvantage to this. It is not as fast as you used to code, because you have to run this build here again. But to make this a bit easier, you can also type watch here, and it will actually watch all your files and see which one changed and generate this automatically. And you can also see this was much faster, but the color is now reflected in our widget here, and everything works as expected. Also, if you have some documentation for your widget, this gets also transferred. And there might be also the case that you need access to your build context that is provided to each widget. You can also do this right here. If you just have some context variable here in here, then we can see it detects automatically that this should not be an argument for our widget, but it should be passed into our function nonetheless. This already is pretty powerful, but there's more, and you've already seen this in the beginning. We can also apply this principle to files, packs, and also the project itself. So let's say we want to write a new Minecraft function. There we can just use the annotation @func. Be aware that this needs brackets here, because you can have some additional arguments here. I'll talk about this in a minute. And now this is not a function, this is just an ordinary widget that should be inside of the function. So I like to use final here. You don't have to, but this ensures that you can't change this variable. Then of course this must be a widget. Any other type will not work. And then the variable name will also determine the name of our file. So let's name it load. And this will just be in for.auth. And now we also want to use say hello. Of course you might be tempted to just invoke this function here, but then you also have to pass in the context. This is not how you want to do it. You want to use the uppercase say hello. This is actually the widget that was generated before. And here you can say hello world or hello Steve with some additional color like color.black. And this is everything for a function. And I also find it really convenient that the name gets also automatically implied from the variable name here. And essentially what it is doing is it generates another final variable and wraps everything inside of this file here. There are a few properties of this file. How can I access these? It is in these parentheses up here. So for example, you can override the name of the file if you're not happy with this name right here. But you can also change the pack. This makes only sense if you try to execute it, which you can also do with the bool right here. Or you can also set the path, and for this case we want to have it in the root, so let's go for it. And then the last thing is if objD should create this file, so it will actually write this file to your file system, or if it just should be a widget. But in most cases you're pretty much fine with name and the path. So let's also do this for our main function. This will be again a final widget main, and this will be our execute here. Just some little widgets that make the entire Minecraft world a bouncy castle. But you can see this main file here is also generated. And also notice the file names here. These are all uppercase, and this file here at the end is appended to the usual name. So if you want to use it, now this would be the time to use it, because we want to of course also generate a pack. and that can we do with these abbreviation for pack, again with brackets. And what is essentially a pack? Well, it is a list of some files, and let's just give it the namespace anot. And now we can just say here we want to have the load file in there, and we want to have the main file. And there we go, we defined our pack. Again, the code generation in the background generates this widget here called the anot pack, and just encases all the properties that we have inside of a pack widget right here and generates everything. And for the files, it just takes our anot array that we defined here. Well, if you worked a bit with objD, you might have noticed there's a slight problem, because our load file is not actually the file that is defined under load, and main isn't either. So there has to be some way to define this, and yes, there is. We have a main and a load property inside of our pack, and these are just strings for the file names. So load would be load for us, and main would be the main.mc function, and this plainly corresponds to these names here that you've chosen for the files. And of course you can also override the namespace like you have done with the function. And maybe I should not name this main here, because this is actually our main function for any Dart program. So let's name this tick. Then you can see the old main file also disappears. So we have to rename this tick file. So, and now the coolest thing of all is the project, I think. This is essentially just a widget that should be the root of all our packs and files and so on. And of course we have to give it a name again, anot pack. So this should be the only contents of our final project here. And again, in the annotation.dart, you can see a bunch of code is generated here. What is so convenient that this automatically generates the main function. So you don't have to do something with these args here and try to remember that you have to pass this to objD, and of course also the project here with the name. But I think most of the time you don't want to have this lowercase name here, so of course you can give it a string name here. Let's call it annotation pack, and all the other things of project are also in here, mainly the target and also the version. That is also a new feature of this objD version, that you can just say version should be for 1.17, and then all widgets and generators will adapt to this and generate code specifically for the 1.17 version of Minecraft. And of course, if you want to customize your main method even more, you can also optionally set genMain to false. And what this will do is it will essentially rename your function here to create annotation, so you can call it in your own main method. But I'm quite happy with this, so I will leave it. So now the last thing to do is, does this actually work? Can we write a data pack with this? And therefore I want to show you a quick thing with the objD CLI, if you are a user of it, because now there is also this code generation built in. So we want to run our project, so objD run, I think it was in lib anit.dart. Oh yeah, I should probably mention that this generator will just look at the files in the lib folder, so you have to write your data pack in there. But then you can pass the flag gen, and you can see it runs the Dart code generator here, and then the objD specific one, and it generated this annotation pack. There we have it. And it also has the load and tick function here. So this is pretty much the same data pack as the other one here that was a little bit more confusing. So that would be annotations in objD. Of course you can spread it across your entire project. Just keep in mind that you have to tell Dart that you actually want to use the g.dart file here. The last thing for me to do is to give you a few quick tips, especially how to use this with VScode. Actually, the Dart extension in VScode has this build runner built in, so you can just press Ctrl, Shift and B, and there you can see you can also execute these tasks here and will build everything as expected. And because this is a VScode task, you can also use it in your launch config. So you can press F5 and usually this window here opens where you can configure which Dart file you want to run. Of course, this should be your main file here. And then you can also say pre-launch task. So this will actually execute a task before the program here is launched. And there you have to insert this right here. This is basically the same name as you've seen in the menu here for the tasks. If you hit F5 in VScode, it will first build with the build runner and then also generate your data pack. And in VScode you can also hide these generated files if you don't want them in your project, because it can be a bit messy. So if you go into preferences and settings, you can search for exclude, and there you can say which files to exclude, and there you want to basically add this right here, which basically says in any folder exclude anything that is named g.dart, which is our generated file. And then you can see the annotation g.dart is not shown here in the file tree, but of course this is your decision. Maybe you also want to look into this generated file. So if you want to know a bit more about these annotations, you can always go to objD.cvitas.com, and in the CLI tab there you can see also the objD gen package, and here you have some more examples and every property detailed, documented. So take a look in the description. And of course I also want to know what your thoughts on this new objD feature are. Do you have any ideas to include new concepts? Just let me know. I hope you have a wonderful day. See you soon.